Here's an example of a bridge or a beam problem. Bridge and beam problems have supports along somewhere along that platform, either above or below the platform itself. In this problem, number 4 on the guided practice sheet, there is a bucket or a pail on this scaffold, and the scaffold is supported by 2 ropes. And the question asked, what is the mass of the man if he can get to both ends without tipping over the scaffold? In other words, it's safe for him to go to both ends. And so what's the maximum mass that would be okay? Now, I want you to think about this first. So I've kind of added on all of the given information here to start with. Which end is more safe for the guy, right? If the painter walks out to the right, he is going to have this pail here to balance him, right? It's going to produce a torque that's going to enable him to go out to that end, right? Because there's more balancing besides the scaffold itself. If he walks out this end, this pail now takes away from the allowed mass that he can have. So this end is less safe than this one. So if we find out how much he can be over here, then we can stop there. We don't need to do both sides, right, in order to figure this out. Now, what happens when you have these 2 supports here? So let's take a look again. Let's just use a ruler. If you have 2 supports, right, then if somebody puts a force at one end here, the force, if there's too much, it'll lift off of one support and the other support becomes the fulcrum. This is true whether the support is above or below. If there were 2 ropes hanging here, well, if you walked out here and had too much force, it would tip up, putting slack in the one string and making the other string the fulcrum. So what we're going to do then is we're going to say that the guy is walking out to this end here. And when he gets, because this is the unsafe end, so the maximum mass he has here is the limiting factor, right, for this problem. And what happens when he's out there is that this becomes the fulcrum and this tension goes to 0 because that's going to go slack if he weighs too much. And from this point we can figure everything else out. So let's put our forces on here. We've got the force of the center of gravity, you've got the force from the pail, and you've got the force of the man here. So those are your 4, sorry, let me do that in a different color. Right, those are your 4 forces. The force of the man, the force of the pail, and the force from the center of gravity of the scaffold itself. So net torque clockwise equals net torque counterclockwise. All forces pulling this way around the fulcrum are clockwise, and force going this way is counterclockwise. So our clockwise torque is going to be the force from the center of gravity times its distance. Now these are all right angle torques. I'm not going to worry about putting in sine of theta. Plus the force of the pail times its torque times its distance from the fulcrum. And that's going to equal the force of the man times his distance from the fulcrum. So the force from the center of gravity is 31 times 9.8, and the distance is halfway, right? So this is the 3-meter mark here, right? If we make this, whoops, yeah. If this is 0 and this is 3 meters, this is 1.5 meters, and this is 1.25 meters. So you can then figure out this distance between the center of gravity, and here is, oops, that's not the center of gravity, this one, right, at the 1.25 meter mark to the 3 meter mark is 1.75 meters. Now the force of the pail is 6.3 times 9.8, and the distance of the pail is 1.25 meters. and the force of the man is his mass, which we don't know, times 9.8, and his distance is 1.25 meters, because he's all the way at the end of the thing, okay? So now you can do the math out. You know, if you want, you can see G is in all of these. You can cancel those out if you like, and then do the math from this point, and you should get, so let's do the math. 31 times 1.75 is 54.25, and 6.3 times 1.25. Oh, this is not 1.25, this is 0.25, right? Because the distance from the fulcrum to here is from 1.25 to 1.5, so that's 0.25, so make sure you correct that. So let's do that again, 6.3 times 0.25. So that's 1.575, and that will equal the mass of the man times his distance from the fulcrum. So you get 44.7 kilograms is the mass of the man, and this is the maximum. Anything greater than that, and he won't be able to walk all the way to this end. If you did the other side, you'd be able to get a greater mass, because this becomes the fulcrum. So this has a more of a torque, this pail, so because it's further distance. So you'd be able to have a heavier mass man stand over on this side to balance that out.